Greetings and welcome. In this session, we will discuss about the construction and working principle of Pitot tube. In a last video session, we have seen about the construction and working principle of first application of Bernoulli's equation as a venturimeter and second application as a orifice meter. In this video session, we are going to see construction and working principle of third application of Bernoulli's equation as a Pitot tube. Pitot tube is a small tube bent at right angle which is placed in a flow of which we want to measure a velocity. So it is used to measure the velocity of flow at any point in a pipe or channel section. Now it works on the principle of Bernoulli's equation. Means what? Bernoulli's equation has three kinds of energies: pressure energy, kinetic energy, and elevation energy, means datumenergy. Now as the pipe is horizontal, then at a different point elevation energy remains same. So remaining are the two energies, that is pressure energy and kinetic energy. So here, when there is a change in one form of energy is taking place, that change is converted or reflected in another energy. So here, this tube is a place. So at this point, when the fluid is coming, at this point velocity of the fluid is ideally, we say, becomes zero. Means here velocity becomes zero means energy in the fluid, that is a velocity, kinetic energy, that kinetic energy is converted into pressure energy. So this increment of pressure energy in terms of rise of fluid we show in this tube, and that is what measurement of velocity. So velocity given by the Pitot tube here is in the form of height of rise of liquid column inside this tube. This is schematic diagram of Pitot tube construction. Here this is a pipe through which fluid is flowing. This is a upstream side, this is a downstream side of the flow. In this pipe, this is a piezometer which is fitted, and this is a Pitot tube, that is a tube bent at right angle. This is an open end to the atmosphere, and this is the other end which is open to the flow. Now in this flow, here at the location where piezometer is fitted, this point, that is we say as a point number 1, and another point where the end of this tube is located, that we say as a 2. Point number 1 is called as static point. Here the flow is flowing, so pressure at this point is called as static pressure. So it is denoted by letter PO as a static pressure. Velocity of the fluid at point number 1 we say as V1 is equal to VO. O we use later for static. Now this is a second point where the velocity of the fluid becomes 0 ideally. So at number 2, this energy in the form of kinetic energy is converted into pressure energy, and this pressure energy we observe here in the terms of rise of this liquid in this tube. So at the point number 2, we call this point as a stagnation point because velocity is ideally reduced to 0. So at this point pressure we say PS, stagnation pressure. Now this rise of pressure we see in the form of height. So for that we use letter HS. So HS is what? Stagnation head. Now these heads, static head and stagnation head, can be written in the form of pressure head. So we have seen in a Bernoulli's equation that head is equal to pressure divided by specific weight. So by that concept, static head is given as HO is equal to PO by W, and stagnation head is given as HS is equal to PS by W. W is a specific weight of a fluid which is passing through this pipe. Now, difference between this stagnation head and this static head, that is given by letter H. HS minus HO is equal to H, which is called as differential head. Further, this is equal to V1 square by 2G. How it comes, that we will see in a further discussion in the expression. So we will see as an expression. For that we will use Bernoulli's equation. So we use Bernoulli's equation between point number 1 and point number 2. So applying Bernoulli's equation between section 1 and 2, we write the equation P1 by W, V1 square by 2G and Z1. Summation of these three energies. These are pressure energy, kinetic energy and elevation energy. These three energies sum is at point number 1, that is a static point, is equal to summation of energies at stagnation point, means point number 2, that is P2 by W, pressure head, velocity head and elevation head. In this, as we say, ideal fluid, thus losses are neglected. As the pipe is horizontal, Z1 is equal to Z2. So these Z1 and Z2 terms will be omitted. By the definition, we say P1, that is a static point pressure PO. P2, that is a stagnation point pressure PS. And at a stagnation point, means at point number 2, velocity is 0. So substituting these in the equation, we find the modified equation, that is what P1 by W becomes here PO by W. V1 square by 2G as it is. Z1, Z2 terms are getting omitted. P2 by W, that term becomes PS by W. And V2 square by 2G, this term, because of this 0, this term is getting vanished. So this equation we write in the form of head. By the definition, PO by W is a what? Pressure head at static point, that is HO, plus V1 square by 2G here. And PS by W, the stagnation pressure head, we write in the form of HS. Now, if you take this term on the right side, we find V1 square by 2G is equal to HS minus HO. By the diagram, we have seen that HS minus HO is a what? H, means differential head of the Pitot tube. So V1 square by 2G is equal to H. Further, by arranging the terms, we get V1 square is equal to 2GH. Taking the square root of both sides, we get V1 is equal to square root of 2GH. So this is the formula for theoretical velocity of the fluid passing through the pipe. So this is a theoretical velocity at point number 1. Now we have coefficient of velocity, hydraulic coefficient, that is a ratio of actual velocity to theoretical velocity, where the range of CV value is given 0.60 to 0.65. So here this V actual we write in the form of theoretical velocity. So V actual is equal to CV into theoretical velocity. Substituting expression for theoretical velocity from this, here we find V actual is equal to CV into square root of 2GH, which is the formula for actual velocity. So in this video session, we have seen about the construction and working principle of Pitot tube along with expression for the theoretical velocity and actual velocity with the help of Bernoulli's equation. Let us meet in the next video session. Thank you.